friends and future friends, to my talk about Streamlined Kubernetes troubleshooting. I know this title is quite a mouthful, but just a quick disclaimer, it's about troubleshooting applications running on Kubernetes, not about troubleshooting whole clusters of Kubernetes. And there's going to be some live demos, but don't worry, I sacrificed the demo gods to my dog this morning, so everything should be okay. First, a little bit about me. My name is Lena Fuhrimann. I'm one of the co-founders of Bespinian. We're a small consulting company from Bern focused on cloud-native technologies. So we focus on the whole Kubernetes ecosystem and everything around it, but we also do a lot with public cloud providers like AWS, GCP, or Azure. Let's delve right in. Who of you knows these folks? Some of you. So those are honorable members of the Cloud Native Computing Foundation. The one on the left is called Captain Kubi. He's the conductor of Kubernetes, which is represented by his ship here. And he always looks very angry, but in fact, that's just his eyebrows. He's actually quite friendly. On the right, there is Phippy. Phippy is the giraffe, and she's a small application running on Kubernetes. So she has her home in Captain Kubi's ship. Right here you see the awesome moment of when she when she finally finds a home and gets accepted into Captain Kubi's cluster. These characters I took from the awesome book, The Illustrated Children's Guide to Kubernetes, which I can highly recommend. It's not just for beginners. So Phippy, as an app running on Captain Kubi's ship, encounters many dangers. There are quite a lot of monsters and horrors that endanger her. For example, there are crashes that she can run into, there are errors that she can run into, or the app can just simply not do what we expect it to do. Some of the common monsters that we see in the wild are those ones. By your laughter, I take it that you have all encountered at least one of those and have at least lost some hairs over them. So let's try to kind of structurize those a bit. Let's try to put them into categories. We follow our friend Phippy. She has an endeavor where she wants to fly into space together with Captain Kubi, whom you can see here just by the little eyebrows. So they want to fly into space, but before the rocket, which is the application, even takes off, a lot can already go wrong. The rocket can have no fuel, it can crash before it even starts, and the same obviously can happen to our applications. The container cannot even be created sometimes, or it cannot be scheduled on the cluster, or the image cannot be pulled. There are many things that can go wrong before the application even starts. And we call this category of failures, startup failures. So startup failures are one of the two larger categories, and they happen before the container even starts. A good example of startup failures are those ones that you see here. So image pull back off, and error image pull, which I think is sort of the older version of that one that we don't see that much anymore. And there are three potential causes to this category of errors. One is that the image that we're trying to pull doesn't exist, or we kind of have a typo in the image name or something like that. The next thing to check for is if the image name is correct, then the tag can still be not correct. So we can try to pull an image with a tag where the image is correct, but the tag for this image doesn't exist in the respective repository. And the third way of how we can get to this error is if we are trying from a registry that is not available or that is private. So the registry, it can be that we need to authenticate with the registry with respective credentials. Another category of errors that we see quite a lot are run container error and create container config error, which by itself is even a mouthful. Usually we see those errors, especially the create container config error, when there is something missing for the pod to start up. So for example, if we have configured the pod to start up with a config map or with a secret, and the respective resource doesn't exist, then this can get us into these kinds of errors. Another category of startup failures that we see a lot are container creating and pending, and I'm sure that you have seen many of those because those are actually quite annoying to debug usually. They can have different types of causes. So the pending one usually means that there are not enough resources available in order to schedule our container. So this can mean that there are resource quotas on the namespace that we're trying to deploy into, or it can mean that our whole cluster is full. So the resources that the app is requesting go beyond what our cluster has to offer. It can also mean that we are trying to mount a pending persistent volume claim, PVC, or the container creating can mean that we are trying to mount a volume, and the source to that volume is a config map or a secret. So for example, you can mount existing secrets or config maps as a volume into a container, and if those don't exist, then confusingly we don't get the previous error, but we actually get the container creating one. So let's look at that in practice. Sorry, I have to shuffle my screens a bit. And I actually have to look over there for coding because I couldn't mirror my laptop screen. So hopefully if it's big enough for me to code, then it's also big enough for you to see. What I have here is cluster, ignore the errors above. Those are just because I was a cheap ass and have K3s running on my laptop. Which is not properly set up, apparently. But at the bottom, you see the different deployments that we're working with here. And you see they're all named after Phippy and her friends, obviously. There's Linky, there's Phippy herself, there's Lena, there's Goldie, and so on. And as you can see by their state, our cluster is actually in a very bad state because none of our deployments are actually working. What do we usually do here? The first thing I would recommend is to run a kubectl get pods. And as you can see here, what a surprise. We have all of the different error categories that we saw before. And there's usually a streamlined way of how to find out what is going on here. So, for example, if we look at the Phippy app, we can do a kubectl describe of the pod. And this gives us a lot more information. If we scroll up a bit, we even see the image that is being used, so the one that it is trying to pull. In this case, it's Nginx. Some of you are already laughing, thank you. And down here, if we look at the events, then we can see a bit more information on what is actually going on and what might be the cause of our failure. In this case, you see it is trying to pull an image from Docker Hub, which actually doesn't exist because silly me made a typo when writing Nginx. Let's look at another example. If we, for example, look at the Linky pod, here again, down in the events, we see a lot of useful information on what is actually going wrong. So in this case, as we already anticipated, things are going wrong with how the application is being scheduled because there's not enough resources. So again, we see this repeating pattern of using get pods in order to see the different statuses of our containers and pods, and then use a describe to see what is going on in the respective pod. Now if we go back to our little story, there we go, then Phippy gets approached by her friend Moby here. And Moby is, as Phippy's troubleshooting, Moby talks to her and she says, Phippy, this is quite silly. We're doing the same things over and over again. We're always running the same 3 commands. Oh, the joy. Oh, the fun, says Phippy, because she's actually having quite a lot of fun running those 3 commands over and over again, because it's quite a mundane, silly task, and she likes the simplicity of it. Let's introduce you to another member of our small family here. Let's introduce you to Lena. Lena is Captain Kubi's older sister, and as you can see, the mighty eyebrows, they run in the family. But Lena has found a good way of styling them a bit more in order to manage her mighty eyebrows. But Lena is the smart one of the bunch. So whenever you see her on our slides now, she's trying to give us a tip on how we can improve our processes in order to troubleshoot and debug our applications. So Lena's first tip is to actually check the Kubernetes documentation. Duh. Because the Kubernetes documentation actually has quite a lot of information about troubleshooting applications, where it starts from debugging pods and then goes to debugging services, stateful sets, and so on. So if you're having trouble troubleshooting applications, then the first thing Lena recommends is to go to the Kubernetes documentation and actually reading up on that. Another tip from Lena is again from the Kubernetes documentation. There is a quite useful cheat sheet from Cubectl where it has a list of, or it's quite a condensed list actually, of the most useful commands that Cubectl offers us. And a lot of them are there to actually help us know what's going on in our cluster and therefore help us to kind of troubleshoot and debug our applications that are failing. And Lena wants to really point out one command that she has found in there that she found very useful. So instead of, if we have a look at the picture that we had before, instead of going through all of these applications, doing get pods and describing them and then looking at the events and so on, what Lena usually does is to run the get events command, and then she applies the field selector with type warning. Let's see how that looks in practice. So as you can see, this gives us kind of a summary of the latest warning events. And this tells us kind of in a kind of condensed and summarized way about everything that is going wrong in our cluster or in our namespace. So these warning events are really helpful in order to see what is going on. And usually if everything is running smoothly in your cluster, then you won't see any of these warning events. So thanks, Lena. If we get back to Phippy and Captain Kubi, they have now made it into space. Captain Kubi still looks a bit angry, but I think he's actually quite happy. And Phippy actually does look happy because she made it through all those startup failures. But now that they are in space, obviously they're not safe because things can still go wrong. So mid-flight, their systems can fail, they cannot know what is going on anymore because the windows can get foggy and so on. And if we port that onto our analogy of an application again, the application obviously can still fail even after the container has been created and scheduled. And we call this category of problems runtime failures. So those are the 2 big categories of errors that we want to look at today. One is startup failures, which are the ones that we have looked at previously. And the other one are those runtime failures. A typical runtime failure can result in a crash loop backoff error that we can see in, if we do Cubectl get pods again, then we see a lot of those crash loop backoff errors. And if we look at the example, then as you can see, We have the Hazel app, or the Hazel pod in this case, which is in a crash loop backoff. And you can also see that it has been restarted 11 times, which is usually not a good sign. If we have to restart our application mid-flight 11 times, you're gonna have a bad time. So again, let's try our method that we have looked at before of describing the pod. And in this case, you see the setup is a bit more complex because we actually have two containers running. One is the web container and the other one is the database container. But as you can see this time, the events don't give us that much information because it just tells us that the application is backing off from restarting, which we already knew, so thanks for that. But it doesn't actually tell us much more. And Lena whispered to me that what she usually does in this case is she uses Cubectl logs on the respective pod. And as you can see here, this shows us useful information this time because it shows us that our app is crashing because it cannot ping the database. The database is apparently not reachable. So going back to our story, Moby comes along again to Fippy, and Moby tells Fippy the same thing again. Fippy, this is a bit stupid. We're running the same commands all over again. We're running kubectl get pods, kubectl describe, kubectl logs, and so on. It's very annoying to debug all these things. I don't want to play this anymore. But Fippy says, oh, the joy. I love doing this. I love debugging my applications in this way. But happily, we have Lena, who can help us out again. What Lena usually uses is an application called Stern. This is a command line tool that you can use to see the logs of, for example, a whole deployment. Because what we saw before is that actually here we only see the logs of one container, namely the web container. But obviously, things are not always going wrong only in the web container, but they can go wrong in all of the containers. And things can get even more complicated if we run multiple replicas of our application, because all of those have their separate logs that we need to go through by running kubectl logs and then specifying the container and the pod of the replica. So this can get very annoying, and that's where Stern comes in. So what we can do is we can give it a label selector that in this case points to all of the containers of this deployment Hazel. And when we run it, then it shows us an aggregated view of all of the logs of all of the containers, of all of the replicas that kind of go into this deployment that match this label selector. And you can see here on the left, it always tells us which container we are looking at. So these are the logs for the DB container. And here we can see the logs of the web container. And if there were multiple replicas, it would even color code them so that you can more easily distinguish them and then select maybe the log to see the logs only one of the replicas. Another tool that Lena, I have a colleague whose name is Paulina, so that's why I always mess it up. Another tool that Lena usually uses is called Kubernetes GPT. And of course, the GPT and AI world has also made it into our lovely Kubernetes environment. And there is now a tool that allows you to use AI to debug your Kubernetes clusters. So what you have to do here is you have to provide an API key to OpenAPI, and then you run an analyze command on your whole cluster, and it sort of tells you a bit what is going wrong. The output might look a bit like this. So it tells you exactly the objects that are failing, it tells you what is wrong with them, and it tells you what you can do about it. But there are a couple of downsides to this. One of them is that there is a freaking wall of text. The other downside is that you actually have to provide your own API key for OpenAI, which is free at the beginning. That's how they lure you in. But then at some point you will have to start paying. That's why there is a screenshot here and not me demoing, because again, I'm cheap ass. And the third downside is that at the state AI is at the moment, it's fun to play with, but there are a lot of false positives, a lot of false negatives, and so on. So Phippy is quite sad, because she has to use all of these tools that are not optimal in order to troubleshoot and debug her applications. Luckily, Goldie comes along, and Goldie has a cool present for Phippy, which he gives her. And what this present looks like is a bit like this. Now you know why Phippy is crying. So Lena tells us what the present is all about. The present is a flowchart that you can follow, which credit goes to Daniele Polencic from learnkates.io. He created this chart, and it's a simple flowchart that you can just go through, and it's kind of a decision tree. So it has all of these points where you can take this, where you have to answer questions. For example, is there a pending pod? And then you answer yes, no. And depending on what your answer is, you go to the next command that you have to run. It even tells you which commands you have to run. And then at the end, you land on one of those yellow boxes, which then tell you what you have to do in order to troubleshoot your problem, or in order to fix your problem even. But Goldie's gift doesn't stop here, because, short disclaimer, this is only a third of this chart. So the chart is actually quite complex, and it's in itself quite complex to work through. But luckily, Lena has crawled the web. And she has found a tool that we have created or started to create at Bespinian. It's an open source tool, and we're kind of releasing this today, more or less. I would love if some people of you wanted to contribute to it. It's completely open source, even without any enterprise licenses or stuff like that. And what it does is it goes through this chart, and it actually automates the chart for you. So it talks to the Kubernetes API, and it takes all of these decisions for you. It answers all of the questions for you, and all it does is it displays you the instructions from the yellow box, so that you know exactly what is going on, what is wrong, and what do you have to do in order to fix it. Let's see it in practice. Let's look at our deployments again. And let's start with the most top one. So what you can do now is run livelint and then the check command in order to check on a specific deployment. Then you just give it the name of the deployment, and it tells you exactly what is wrong in this case. So with the Lena deployment, it tells you some checks are okay, but some checks are also wrong. So there is one pod that is not running in this case. And then as a consequence of that, there is one container that is still being created. As a consequence of that, the source secret of the volume that this container is trying to mount doesn't exist. So it tells us to create a flipping secret. So I don't have to do any kind of describe, any digging into my cluster. It just tells me for my deployment what is wrong and what do I have to do. In this case, it's just checking the pods, but it doesn't stop there. So if everything is right with the pods, then it also checks your service for you. If everything is right with the service, it also checks your ingress for you. So it does all of this work for you. We can look at some more examples. So let's, for example, check the, what else do we have? The Phippy deployment. In this case, the tool cannot figure out whether the name of the image is actually correct or whether the configuration is just wrong. So it asks you the right questions. In this case, it asks you, is the image name correct? Obviously, it is not, so I choose no. And it tells me to fix the image name. Thanks for that. It doesn't tell me yet what the correct name would be, but I guess we need AI for that. If I lie to it, if I would say, okay, this is the correct image name, then it asks me, is the tag latest a correct one that exists? Again, if I tell it yes, then it asks me, am I trying to pull from a private registry? If I say yes, then it tells me that the registry is actually private and that I need to configure a secret for that. Let's do one more. Cubectl. Sorry. Live-lint. What it also has is a verbose flag, which gives us a bit more information. So, for example, if we run that on the Goldie app, you can see that it actually gives me the output of the relevant things that I would look at when I would run kubectl instead. So it tells me in which status the pod is, it tells me exactly which config map is not found, and those are texts directly taken from the Kubernetes API, which is also what the what kubectl uses in that case. So if they're not troubleshooting anymore, they live happily ever after. As are we. So as I said, I would really love you all to contribute to this awesome tool. It was really fun writing it, or it actually still is really fun writing it. The cool part is that because it is written in Go, obviously, and because we use the official Kubernetes API client package in Go, we learned so much about Kubernetes, about how its internals work, and about what the different problems are that can come up, and so on. So it was really a great learning experience. And my kind of fazit about the Kubernetes client in Go is that it's very powerful, but it's actually quite troublesome to use. It's actually quite annoying to use. So we would really love some support. And for that, I would like to thanks a lot for the attention. And if you have questions, let me know.
Thank you very much. Are there any questions? So there is a mic in the plant there, over there. You can.
Thanks for the talk. Can you also troubleshoot stateful sets or any other resources?
Sorry. After you've made a PR, we can. So no, there we aren't yet. But we're actively working on it and adding more checks. We have even started to add some checks that are not in the flowchart that we think are helpful, but there's still a lot of cases. And we also want to introduce that you cannot just troubleshoot starting from the deployment, but if you have a pod that you created directly, that you can start there, or that you can start from the service or something like that. But that's still open. Thanks.
Yeah, I can just ask this way. Yeah? Oh, okay. Thanks for the great presentation. Nice book. I wonder, your decision tree, like it's based on that diagram. Do you think to improve or develop it? Like, for instance, an example you had when for private repository, you had a secret, but it's also like the secret can be there, but it can be wrong, so it could provide like. So, do you think how you could then improve it so it would include more like branches in the decision tree?
Yes, thanks for that question. So we have already added some more branches. We have actually in the repo itself, we have a draw.io file that contains sort of our continuously improving flowchart. So we're trying to add new features, and also we have to constantly update it because the Kubernetes behavior and the API constantly changes with every version. So we have to keep it up to date, and for that the client package in Go actually helps us quite a lot, because we know it's a sort of a first-party package and it always represents the latest state. Thanks.
There is still time for one additional question. Then a round of applause. Thank you very much, Lena, for your talk.